Hello, everyone. Welcome to join our online webinar today. Hope everyone is doing good. And my name is Michael, a solution engineer from DJI agriculture team. Maybe somebody of you already know me. Very glad to meet you, everyone here. And I will start our webinar today. And today our topic is practical drone solutions and workflow in wheat farming. And today we are very honored to invite Mr. Ryan to share his work on drone applications. Ryan is the owner of Veteran Drone Services, and he has been operating drones for many years and has over 2 years experiences of drone spraying and spreading. Hi, Ryan. Can you say hi to everyone?
Hey everybody, how you doing?
Okay, thanks, Ryan.
Did you hear me?
I
Did
think
you hear me? Okay.
yes, we can hear you. The voice is good. Okay. Thanks, Ryan. All right, everybody. Now we will start the webinar today. And today, three chapters will be included for today's presentation. In first part, I will introduce the advantages of drones application and its application opportunity on wheat. In second part, Ryan will introduce his workflow and practices of drone on wheat, like crop monitoring, mapping, spraying, and spreading. In the final part, I will introduce some solutions with the consideration of drone drifting and rolling hills. And here is the first part. And the first topic is advantages of using drones on wheat. When we talk about wheat, drones' flexibility and availability will always be the biggest advantage compared to conventional machine like ground sprayer and airplane. And I think the biggest deal for drones' advantage is after rain work ability. As we know, in April and May is a very key window for the fungicide and insecticide application on wheat, but in some regions, it's rain season. And with the agriculture drones, we won't need to worry about any situation like this. The machines trapped in the muddy field, and you cannot work anymore and miss the operation window and got a better result in the summertime is a better result, right? And but with agriculture drone, I think we can do the spring operation immediately after rain. It's a very big advantage and compared to the ground machine. And the second advantage is obstacle avoidance ability in the field. And as all we know, active radar and binocular vision system on the agriculture drones will always help you to get a good sensing about the obstacles in your fields like power line, irrigation, pivot, and trees around the field's boundary. And those things always exist in your field and very unfriendly to airplane. So with an active drones, it will help you to avoid such risks. And the third reason is rolling hills. In Western states and where people plant lots of wheat, and lots of the fields are rolling hills in Western state. And in middle region like Missouri and Kentucky and Tennessee, for the reason of water flash, people told me they will plant the winter wheat on the rolling hills to protect the soil. And with terrain full ability of the agriculture drones, it will help the drones be capable of flying over such landscape, right? And also in the final part, I will introduce the rolling hills solution about regarding to the agriculture application and to show how does it work, how the drones work on the rolling hills. And this page will tell us when we can use agriculture drones for wheat. If we use fixed scale to describe wheat development stages at the stage one, especially after rain, we can do the after rain spraying to spray the emergency herbicide, and also sometimes use the spot spraying to apply the herbicide, right? And at stage 4 and stage 7, usually we will observe the status of the crop, crop status in the field to see if there is any herbicide and any weeds on the field. We will, based on the situation, we will decide if to perform additional herbicide application and insecticide application. But the very, very key stage is from the stage 10 to 10.1. It's a very, very good window to apply the fungicide on the wheat. And it will be around 4 to 7 days. It's a very short window. And also, so like the Korean soybean, fungicide application is the biggest deal of drones application on wheat now. So this is the first part. Advantages of drones application on wheat and when we can use the drones on wheat. Next, I will hand over to Rhyan, let him to introduce his experience of drones application. Let me welcome Rhyan. And next, I will move the page on, and Rhyan, and you can unmute yourself.
All right. Thank you, Michael. All right. Good morning, everybody. Like I said, we're going to go over a little bit of kind of my background, where I come from, kind of what I've seen workflow and operations work on the field edge. And then we'll turn it back over to Michael for some terrain stuff we've been working on. As you guys can see on the screen there, my name is Rhyan Syester. I own Veteran Drone Services. I don't come from an agriculture background, so I'm learning the agriculture side. I come from a military background where I just retired after 24 years of service in the Army. So I'm learning. My learning curve is way bigger than yours is. You're just learning a drone. I'm learning agriculture. So big learning curve for us on that side of it, but we understand the drone. So we do custom application, we do consulting work, we train dealers and pilots, and we train technicians to repair them. And we didn't spray and spread quite as much as we had hoped to get done this past year, but it kind of got into training and teaching, kind of took a lot of our time. Just a couple of pictures you guys can see there on the screen. On the left-hand side there, that's kind of our setup we use when we're seeding some heavy cover crops. So we just use the seed tender there and operate off of that. Oh, back up one, Michael. There we go. Okay. In the middle, there's just some technician training we were doing. We were, completely disassembling some drones all the way down to the bare components, and then building those back up to help understand how they work and what's happening. And then on the right, there's just some dealer training we're doing. So that's kind of what we do. It's a little bit of my background and what we've been doing and what Veteran Drone Service is, just to kind of give you guys an idea of where I'm coming from on this. Next slide, Michael. Okay, so a lot of what makes, in my opinion, the DJI system and family of products so valuable is the workflow and the complete vertical integration. So we use the Mavic and the RTK base station, the relay, whatever we need of those parts. As you can see on the left there, we go out, we get our crop info, we bring it up, take all of our images, get all of our pictures, we process that into map data. We use DJI Terra or the Smart Farm Web. I personally prefer the Smart Farm Web. It doesn't quite do as much as the DJI Terra can do, but it also doesn't require quite as much computing horsepower. So I can get that done with a computer I already have at the house without needing a large lot of RAM and data processing power on my computer. And that does about 90% of what most farmers need it to do. So we use that software, all easily integrated, all transitions easily between the different platforms. And then we get our data for our, whether it's our RGB imagery, whether it's our multispectral stuff, whether it's our 3D flight routes, whether it's our prescription maps, any of those things we need for them fields. And then we bring it down, and then we use our, T40, T20P for us is primarily what we're running. We bring that information down in those drones. We do our application, and then that information goes back up into our management system, and we're able to see exactly what's going on and provide that information there. So for me, one of the big things about the DJI family of products is the fully integrated workflow from their products, and it all seems to transition very well from one platform to another. All right, so why drones on wheat? So a lot of people sprayed, fungicide on corn. A lot of people have done, some beans. Some people have sprayed some cotton, multiple different things. But on wheat, I think one of the big things is, so in our region, I'm from Western Kentucky. In our region, we had record-breaking yields this year in just an absolutely phenomenal wheat crop. And every time we drove down the road, there was, the giant tracks right through the middle of the wheat field going back and forth that were running over some of that cash crop. So the big things I think we can do is, from a very early stage, we can kind of see what our germination's looking like. We can use our Mavic 3 multispectral. We can get in there and we can really see what kind of germination and coverage we got. And we can also see early that we may just be able to do a spot spraying of a post-emergent herbicide to try to cut down on some chemical costs. So there's a lot of things that we can do with that. And then if it comes to putting some fertilizer down in an area, I think if we could use the drones to spot spray weeds and only put our fertilizer where we need it, we can really drastically reduce our input costs and not be running over our field as much. And it generally works out that when we need to be spraying wheat, it's a wet time of the year. You're always dealing with wet fields and kind of, can we get the ground rigs in there to do it? So that's always something that is on our minds. And then when we get to looking at like that weather and soil, like I need to spray it, we know we need to get something on it, but it's not quite dry enough yet. It's really great to have that drone to get out there and go ahead and get started. Even if it's I'm cleaning up those field edges while it's drying and getting some things done before they come through with the ground rig and get the big spraying done. So it allows us to treat every inch of crop that we plant, even in some areas that we normally may not treat because it's point rows or it's back in a funky section of the way the field's laid out, and we're going to run over more than we're going to do good back there. So really think the drone has a big place in that. We use that a lot this year to make ground rigs and airplanes and helicopters more efficient. Okay, as we start looking at best practices for mapping, when we first got into this, I wasn't doing a lot of mapping. I was kind of just working off of the imagery was there, and I really started being able to turn out some acres and get some things done when my prep work was where it should be. So, what are we mapping this out for? When I say mapping, I'm talking about creating new map data, new background imagery of my field. So what are we collecting that information for? Is that just going to give us an updated image of our field? Is that just going to give us an updated image of where the tree line is? We all know those trees grow in at about 5 feet a year, so we know those edges are encroaching on us. So if we go ahead and fly that with the Mavic and we're just trying to get that field edge, we don't necessarily need super high resolution 1080p type imagery and a long time to process that data. We can, lower our resolution, increase the height of the Mavics flying for us, and collect that data with, few hundred, maybe a couple thousand pictures instead of 8,000-10,000 pictures if we're really trying to get high resolution and stuff. So if you're just trying to update the imagery on your field, just put your settings at the resolution that you really need. Usually a medium resolution at 250 feet will really do pretty good. I haven't found a lot of difference in from 200 to 250 feet. The differences I think is pretty marginal, but it does reduce the number of pictures you got to process. So those are just some things to work on. Maybe work on them in the off season, kind of seeing exactly what settings you like based on what you're looking for. But that's always the first thing we're looking at when we're going to map fields out is what am I using the imagery for? Then we get into, like we started to touch on it there, but we get into the right fly height, right? So the higher you fly, the less pictures to process, but the lower resolution. The lower you fly, the more pictures you're going to take, the more pictures to process, but you're going to get higher resolution. So if I'm trying to get really high resolution stuff and I'm trying to really dig down in and zoom in those plants and see what's going on, I'm going to have to fly it lower and take a lot more pictures to get that resolution. Generally, when we're just doing our RGB stuff or our red, green, blue for our regular photogrammetry or imagery updating stuff, I really think that, I usually run somewhere around 200 to 250 feet with maybe a 50 to 60% overlap. I think gives us everything we need on most cases. If I'm trying to get much higher stuff, I'll bump that overlap up more around 70 to 80% overlap. But for most of what we need to do with these, that RGB imagery gets a lot of what we're doing, which leads us into that RGB imagery. So are we trying to produce near differential vegetation index stuff? Are we trying to get that NDVI data and really get to looking at what we're doing? Are we going to write that prescription map? So before I take the time to fly it and process all those imageries, I look at, do I really need that plus MS or multispectral data on this flight? Because it does vastly increase the processing time of that. So sometimes I may just fly it, get my RGB data and use that, and then come back later with my multispectral when we're looking at post-emergent and we're looking at maybe some spot spraying some herbicides or doing some variable rate application fertilizer stuff. That's when I'll come back and get my multispectral, do my NDVI data production. Then I'm kind of looking at that agronomist to be like, hey, here's what we're looking at. What's your recommendations? And they give that recommendation. I can save the farmer a lot of money on input costs. We're only putting down what we need to put down, but we know we're putting it down exactly where we need it to. And then the next thing, after I decide what kind of imagery do I need, I really start to look at how am I going to process that data. So I really kind of spent some time learning the Smart Farm Web, just because the majority of our customers, you can run the DJI Smart Farm Web on your $400 2-year-old Walmart computer, and it works just fine. When you start looking at DJI Terra, it does a ton more. Absolutely phenomenal tool, in my opinion. However, if you don't have the computing horsepower to run that program, you're really kind of just spinning your wheels getting started there. So determine what's going to work best for you. Get on the Smart Farm Web. You get those when you buy your T40 and your Mavic, it comes with it. So get on those two, mess around with them a little bit, learn the Smart Farm Web, learn your buttonology, get on your DJI Terra, figure out what it does, and realize, which one works best in your operation. So the great thing about these drones in agriculture and using aerial application that the farmer has at their control is it's fully customizable, right? So we can take advantage of the things that mean the most to our operation, and we don't have to worry about the things that aren't important to our operation, but our neighbor down the road may really benefit from that. So understand how it best fits into your operation, and then put the drone and the software and the data in position to be successful as opposed to in position to fail. So if every time you're flying, you're doing RGB plus MS and you're flying real low and a ton of pictures, the workflow isn't going to be worth it. The data processing time is not going to be worth it. Now you're going to get kind of discouraged on what it can do and what it can't do. So understanding what you're looking for, what are you trying to get out of this piece of equipment and this software, and then putting in those positions to be successful. So like I said, the majority of the time, I think most of us are going to use just RGB, and we're really using it to update our map data, especially off season. Or early season. We're going ahead and get out there. So we're contracting a lot of acres. My Mavic's out flying now. So it's out collecting data, getting ready for the upcoming season for some stuff that new customers we gained from last year, and then updating anything we did from last year. So now's a great time to be collecting that map data, going out and mapping those fields if you've got those acreage, or if it's your acreage, you can go out and use the Mavic to really start putting together what that farm looks like from an aerial standpoint. All right, so when we start talking about seeding, so there, basically there's two kinds. Are we planting wheat for a crop, or are we planting wheat for a cover crop? So planting it for a crop is obviously a little different rate. We've gone through NRCS, and that's part of your cover crop blend through the NRCS. You're putting some wheat in there. Maybe you got some clover or some back-end radishes, or you got something else in there maybe that's a blend. Well, that's one thing. Or maybe you're actually trying to spread it for planting a stand of harvestable crop in winter wheat. Where we're at down here, we do a lot of double crop beans. So we will plant winter wheat. It'll grow the winter. We'll harvest that, and then right in behind it, and we'll drill beans in. So when we start looking at that field, may get a lot of chemical on that field over the course of 1 year. So if we can, adjust that and variable rate and kind of control what we're doing, it really gives us better growth out of that land. We start reducing some of that chemical input. So now when we go through and we're putting cover crop in it, we're going to get a little bit better. So when it comes to spreading cover crop or anything you're spreading granularly, the number one thing you gotta do is you gotta take the time to do a good flow and weight calibration. So there's tons of videos out there. Everybody can see a video online of how to do it. It's not difficult, but a lot of people want to shortcut that, and that has a big determination really on your coverage of that cover crop or something you're planting. So if you're not getting the coverage you're looking for, talked about it earlier, you're putting the drone and yourself in a position to fail as opposed to a position to succeed, just by not having a good flow rate calibration. So for me personally, I like to set my drone up a few feet. I take my spinner disc off. I like to put a bucket underneath it, and I just let it do those flow calibrations. And I may spend a whole day or so just doing flow calibrations of all the different things I think I might be spreading, because you can create that bell curve, if you will, and then you can pre-save those all into your controllers. So when you come back to it next year, next time, next field, all that same information is right there. So do a good job of a good flow and weight calibration, and then create good, accurate templates. My grandpa used to tell me an ounce of prevention is worth a pound of cure. So the prep work in the shop will save you a ton of time and headache on the field when you're out there trying to get the acreage covered. So accurate templates, good flow and weight calibrations, and then do some testing. People use all sorts of different things. I think one of the biggest popular things is cat litter. You can put kind of anything that you're, testing it on your place, kind of looking at what it is. You can do pan tests. I know some people that have done the sticky mousetrap tests. I know people that just use tarps and calculate square footage and making sure they're getting the rate per acre. And then, deciding what speed, height, and route spacing works best for them. But doing all this prep work beforehand, it's not much, like the workflow is a little different, but the facts behind it is not much different than going out there and prepping your planter. It's not much different to going out there and putting new nozzles and tips and getting your sprayer set up. We put the time and effort into getting everything set up in our tractors and our combines and our spray rigs and all that kind of stuff. We got to do the same thing with our drones, right? We've got to spend the time to get that thing calibrated properly, set up properly, and put it in a position to be successful. And then we take our time mapping our fields. We get a good job of mapping the field. And then I prefer to do all my boundaries for my fields in my shop. So I update my map data, and then I put an HDMI cable between my controller to my 24-inch monitor. I got a little $15 Bluetooth keyboard and mouse that I put in my USB-A port on top of my controller. And I sit down in my shop, climate controlled, and take my time, and I map out those fields because that's part of my prep work, that when I go out to the field, I'm going to get some acreage done. So taking the time to create good fields, create good map imagery, create good boundaries, and getting that set up. Then when you go to the field, that's the easy part. You know, spraying in the field and flying the drone, that's the easy part. It can get frustrating if you don't do the prep work, but I think that's kind of everything we work on in farming or agriculture. I mean, it goes all the way down to painting cabinets. I had to paint my wife's cabinets. I tried to rush through it, and I didn't do a good job taping them off, and it became a giant pain in the butt. So if you do the prep work, it'll pay for itself in the long run for sure. And then if you're doing some heavy rates, if we start getting up to some big heavy rates with the drones in granular stuff, generally I don't like to do 100 pounds is max of what I really am comfortable doing an acre on a single pass. Generally I'll split that up, and I may fly it twice. So I will fly.
Hi, Ryan. Ryan, can you hear us? Oh my God, I think Ryan lost the signal.
Can you hear me, Michael?
Yeah, we can hear you now.
I don't know what happened. Sorry about that.
Yeah, so your side is signal seems not very good. But it's okay now. Your voice is coming.
Yeah. So so when we're talking heavy rates, like I said, I will, say if I think I'm running a 24 or 26 foot swath width on spreading, then I will split the difference on that. I'll rectify that offset, and I'll fly it again, 13 feet over from where I just flew it if it's a 26 foot swath width. So that gives me a double pass in there, because it just starts to get tough to get the seed spread out when you're talking that much seed to get it out there. So if you're doing, large acreage stuff, or, small acreage stuff at heavy rates, that's really kind of where that comes in. But that's just a food for thought there. It's something for you guys to think about when you start looking at putting down heavy rates of planting with your spreader. Next slide, Michael. Oh, before you switch it, Michael, back up one more. Sorry. As you can see in the top picture there, Toby's got the different discs. That does make a pretty big difference of using the proper disc of flow rate in there. So changing that gate out. If you're just running, say we're just doing 12 pounds of clover to the acre, and you're using that big gate that comes in it, it's very difficult to control that flow rate and get it to give you the spread you're looking for if you have that big gate in there and you're looking at low rate stuff. Put that other gate in there, and it's much better control at your fingertips with that. And then we're going to go into, I think Michael's going to play us a video here as we talk about the calibration process and how we're going to create those granular templates. So there's the different gates we were talking about. And those are all your different templates that are going to be in there based off of that calibration that you just did. And in that video there, just for you guys, I prefer to take my spinner disc off. Then I can just put a 5-gallon bucket underneath there, and it all just pours right down into my 5-gallon bucket, and I can pour it right back in the top. But you want to make sure those calibrations are good, and that's going to help with your accuracy and your flow rate for that blend. Can you use your Marshall rye flow rate with some cover crop wheat stuff you're doing? Sure. But is it going to be accurate? No, it's not going to flow the same. Light, fluffy stuff is not going to fly as heavy as small, dense stuff. So it's really important to do good, accurate flow rate calibrations with each product you're using before you put it on there. Next slide, Michael. All right, best practice agriculture drone application. We're just going to kind of go over some basic setup stuff, kind of what we're on trailer, kind of what you're thinking about. I'm pretty sure we got a pretty wide range of knowledge and experience level in here. So this is one of those things that we learn every day. We try new things every day, and so it's going to be vastly different for a lot of us based on maybe what we had when we started, what we've switched to now, different things we've tried. So I'm always interested to learn how somebody else is doing it, just because it may open my eyes to some other things that are out there. So this, I don't think, is the end all be all answer, but this is what I do. This is how I prefer to do it when I like to set things up. So when your first thing you're talking in a trailer setup, you're looking at power. Like, we're charging batteries. Am I using the DJI D12000 IE generator, or am I using a T30 charger with a commercial off-the-shelf generator from somewhere else? There's plenty of variables to go into that, you know. And when you're looking at that power, am I running lights? Am I running an air conditioner on top of my trailer? Am I running electric pumps or gas pumps, or what are we doing there? So those are all things that need to be taken into consideration when you're looking at optimizing your workflow on the field edges. First and foremost is power. Next is bulk water. I put bulk water on there, but bulk water or bulk seed, kind of how are we dealing with that? How's that storage look? What do we think looks the best for our operation, and how much do we really need, right? So when you get guys that have been doing ground rig sprayers and now they have gone from ground rig to drone, they're used to a semi trailer and 4,200 gallons of water on them at all times, and giant tanks and stuff like that. So we shrink this down, like, how many gallons of water do we really need on us today? How much are we really going to get done? How much can we get done with the 2 T40s we're running? What rate are we putting down at? So bulk water storage and how you're going to manage that is probably your next thing. Once you figured out your power solution, now you're going to look at bulk water storage. Chemical transportation, that's something that's often overlooked. Sometimes you'll have to go to the farmer and pick up the chemicals, or if it's your own stuff you're doing, how you getting the chemical stuff there? What does your chemical storage for transportation look like? For me, being a custom app guy, a lot of times a farmer would call the co-op and tell the co-op, hey, Ryan's going to come by and pick these chemicals up for me. I'd swing by the co-op, have to load up all his chemicals, and then I'd head out to the field to get started spraying. So it quickly became like, where am I putting all this chemical storage? So it's just something to think about and take into consideration when you're looking at a trailer setup, whether, and then chemical storage can also be that seed storage. Are you just setting pallets on there? Or are you're running a Pro Box setup? Or are you running a vacuum setup and blowing the seed in there? Are you running a big seed tender setup and you got your Ford F550 pulling a 10,000 pound seed tender behind you and you're using that, right? So chemical or seed storage, like how are you storing and transporting all that stuff? We start looking at mixing seed or blends or coating or treating seeds. I always leave that to the co-op. It's easiest to just pick that up from the co-op. If you're, if it's coating your ear or whatever you're doing with that seed, or the farmer wants done with that seed, how are you mixing that? Can you get it mixed, or do they have a way to mix it themselves? When you're talking liquid and you're talking mixing, like, so plumbing, I plumb all my stuff. I got a clean side and a dirty side. So I got a clean pump that is literally just to move bulk water from my clean water storage into my inductor tanks. And then I've got a separate pump that runs my dirty side, and that's where the chemicals gets mixed in, and I'm circulating and moving the chemicals around in my inductor tank. Then that's what I also use to fill the drone. So clean side does nothing but move fresh water through a check valve into an inductor. And then on the other side of that's the dirty side that's just mixing my chemical, circulating my chemical, and running things into my hose to fill the drone. Once you're looking at plumbing, now we're looking at pumping. So how are we moving bulk water or chemicals? You going with a gas pump? You going with electric pump? How are you going to do your circulation? How are you going to fill it? Do you want, and that gets into, some people want 2-inch hose because they're used to 3-inch and they just can't bear the thought of getting smaller than that. Personally, I prefer 1-inch plumbing for all my water movement and chemical movement, and then I use a 3/4-inch hose for filling the drum. Excuse me. I personally am not a fan of auto shutoff valves. Using your diesel or DEF or gasoline auto shutoffs, I'm not a big fan of those. They kind of pull heavy on my fill through cap. I feel like they start to mess with the calibration on the weight sensor module on that side. I also feel like they induce air into my chemical mix and I get a little bit of foaming in my tank that I'm trying to avoid. So for me personally, I prefer a banjo ball valve with a filler neck on it, and I just turn it on and off that way. So look at how you're going to set that up. Those are all things you got to think about, plumbing wise, size wise, all the things you're going to set up before you're going to go out there and start spraying, winter wheat or whatever crop it is you're doing. And then trailer setup. So are you going to use a big fancy purpose built air conditioner unit on top, alloy rims, full walk on roof, rubber coin floor, electric over hydraulic jack on the front? Awesome trailer. Or are you going to use something you got on the farm? I started out, I used a 16-foot open station car hauler that I had on the farm already, and that's what I used to get started with. So and then as I grew and realized the efficiency I was losing, I kind of started changing that up. So where are you going to start at? Where are you gonna get to with that? Do you want something enclosed? Do you need something enclosed? Do you have something already you can use? Or are you going to have to buy something to get started with? All those things are going to come into consideration when you start looking at how's that setup going to be, and how is that setup on your trailer going to make you the most efficient you can, right? Because it's all about the efficacy and then getting into our efficiency, right? So how can any of those things make you more or less efficient? And let's change the things that are making us less efficient, and let's make sure we do things that are making us more efficient. Next slide, Michael. Okay, we're going to get into, so we talk about spreading, good settings and that kind of stuff there. Now we're going to talk about spraying. Again, good flow and weight calibrations. I calibrate my stuff probably more than most people do or say I should, but I don't get a lot of weight sensor issue errors. I don't get it coming back where it sprayed itself empty. It just works well for me and does what it's supposed to do. And I don't have a lot of the issues people talk about having, but I also do my weight sensor calibrations every time I change a chemical blend mix. It takes a little more time. It's a little bit tedious, but I am very confident when I'm done spraying that field, exactly what happened on that field and how much chemical I put where. So good flow and weight calibrations on that. And then again, doing your testing for your speed, your height, and your route spacing. So when you talk about ground rigs or other forms of spraying, we start talking about, the art versus the science. That's what we're not running over. Well, in this is how are we controlling our swath width, and what are we getting as far as the best coverage we can get? How much of an overlap are we getting? What are we doing to make sure we don't have skips in the middle of the field? How can we get more accurate and increase our efficacy? Use templates. I'm a big fan of using templates on all my chemical stuff. So if I go out there and I'm doing some testing, I don't just put some random numbers in there. I build a template. I build a template because I'm apt to forget what setting that was. And when you're changing those settings so many times, it's very easy to forget what those last settings were that you really like. So I got my little pocket notebook where I write some things down, but I always create a template when I'm making spray stuff so that I can remember exactly what it was. And then if I make changes, I adjust it in that template and try it from there. So use templates. It helps you remember. There's so much going on. You're trying to remember so many things. Use the templates in there to make sure that if you figure out what works best for you on fungicide on wheat, then you know you can go back and spray those exact same settings on every field you spray after that. Again, taking your time mapping your fields and creating your boundaries, that's always going to be huge. If you're creating all your own boundaries and doing it all yourself, or if you're working with a farmer that's pulling your boundaries out of your AFS Connect, if you're a Case IH guy, or your Op Center, if you're a John Deere guy, if you're pulling those shape files out of either one of those things, when you pull them out, don't just trust that the drone's going to fly it that way. When you're talking about those two platforms, a very common platforms in the agricultural community, but they're creating those boundaries knowing that there's a human being sitting in the seat of that spray rig to make real-time decisions based off what he's seeing and not what was programmed in that ground rig to do. These drones, unlike our children, they are going to do exactly what you tell them to do. So if you put them in a position to be up against that field edge or up against that tree line or working around that light pole with the guide wire coming off of it, you're going to have some of those issues. So creating good maps and boundaries, if you do pull them out of AFS Connect or Op Center or SMS even, I highly recommend pulling those up, zooming in on those, going through and looking at them, and you may need to make some little adjustments on it. Much quicker to make a few adjustments than it is to create a whole new farm or field, but it is something that you may need to adjust in there before you get started flying. Again, prep work in the shop will save you a ton of time on the field. It took me a little bit to get my head wrapped around that, of how much more I got done in a day if I just spent an hour or so back at the shop getting ready. And then focus on efficacy, and the efficiency will come. We talked about that a little bit, the art versus the science. So the science, we got a pretty good idea of what these drones will do. Michael and DJI have been great about informing us on exactly what they can and can't do. But then it just becomes us as the users, the end users, to learn that art of it. How do we get the most out of that drone? Excuse me. How do we get the coverage that we're looking for? How do we keep increasing our efficacy and our efficiency without compromising either one of them? So continue to hone your skills, continue to hone your craft. And I always listen to anybody that talks about anything they did with drones, because I learned something new about how they're being implemented in agriculture every day. So continue to, even once you get the science figured out, continue to work on the art. All right, next slide, Michael. All right, I do have to bear with me for a minute, guys. I have been traveling all across the East Coast lately, and I'm headed back west, and I am got some sort of East Coast funk going on that is working me over. So we started looking at best practices. We start looking at spraying efficiency, swath width, flight speed. Everybody wants to try to get their stuff flying at 32.8 feet per second and look at how many acres I covered. And I got my drone to do 45 acres an hour. I don't believe you're getting that done and getting repeat customers next year. We can do some things with our drone to increase our efficacy, and we can do some things with our drones to decrease our efficacy. So when that drone is flying and it's slower, if this is the front of the drone, the slower it is, the flatter it is. The faster we try to go, the more it pitches up and it starts to blow everything back, and we're really not capitalizing on our rotor wash to penetrate our canopy. We're just kind of becoming like airplanes and blowing it out up the back and letting hope and gravity bring it down into the plant. So when you start looking at your swath widths and your speeds, that really varies and changes per crop based off the canopy of that crop. What you got to do to get, through a potato patch to get down into there is vastly different than what you got to do to spray on your cotton. That cotton's pretty easy to get through. Those potatoes are pretty difficult. If you're trying to spray some insecticide on tobacco, that's a big draping plant that you've got to work some rotor wash to get in there, because those leaves are kind of protecting that plant. If we want to get anything in there to the root of that plant, we've really got to work through it. So for high uniformity requirements for spraying, herbicide, T40 swath width should be set at 7.5 meters. So that's like, what is that, like 24-ish feet, Michael? Did my meter calculator work?
23.
Yeah, 23, 24 feet. And then for medium uniformity requirements, you're looking at more of that, at that 9.8. Now you're looking closer to that 32 feet per second kind of realm for medium uniformity. So again, it's not just everybody's like, hey, what are your spray settings? Exactly what? Well, they're different on every crop, and it varies and it changes. You just got to do the testing, I really feel like, to get it lined out, to figure out what works best for your operation. And I've got multiple T40s, and I had to move a couple of them around because the way they operated were vastly different than one another. So these two acted and operated and did the same way and same things. And I had this other one that flew kind of totally different. It was odd, but it was electronics. That's what happened. So I had to put the two that act alike on the same trailer together, and the two that acted the other way, kind of put them on a trailer together. So when you start looking at how they fly and where they really fly best at, maybe it's, has something to do with the settings. Maybe it's got something to do with beating and banging around in the trailer. It's hard to tell. But when you start looking at your uniformity for your swath width and your spray width, it's going to vary, and you're going to have to do the testing and the trials to really get where you're looking at. Michael says that when you're faster than 7 meters a second, when you're faster than 21, your vertical downwash pressure is minor. So the droplet penetration generated by the downward pressure. So like I said, when you're going too fast, you're really not pushing it down in there. And the big thing with these drones, we're trying to capitalize on that rotor wash and use that rotor wash for penetration. Where a ground rig, it uses volume for penetration. So it puts down something at 30 gallons to the acre. Well, we're putting it down with the drone at 3 gallons to the acre. Well, if we're not using our rotor wash to push it down through the canopy and get the good coverage we're looking for, and we're not doing the ground rig flow rate of carrier, then we may not be getting the efficacy we're looking for. So just think about that when you're looking at how you're going to implement it and how you're going to use your flight speed and your height above crop to ensure that you're getting your chemicals penetrated down to where they need to be. Next slide, Michael.
Oh, all right. I think your part finished.
That's your turn, buddy. That's your turn.
Yeah, thank you. Thank you, Ryan. Thank you very much. The code didn't stop you to give us a good presentation. Thank you very much.
It tried.
but it doesn't. Thank you very much. Take care. Thank you, Ryan. And his sharing is really informative, I think, to everyone. And I have learned many more possibilities of drones application on wheat. And next time I will use around 10 minutes to share some new information regarding to the solution recommendation. And first is some updates regarding to the T50 drifting test. And the reason why I mentioned this part is because recently we heard more and more people they start to use drone to spray herbicide and insecticide on wheat. And in such scenario, drifting is really a very key concern. And so in 2023, in 2023 internal DJI, we have performed over hundreds of spring testing under drafting, and we follow the standard. It's on international standard ISO. We call it ISO 22866. It's a standard to test the area spring drifting. And as we can see, we set up two different readings for the experiment field. Left part is normal spring area. Right side in the downwind, this is downwind direction. It's the drifting collection area. In drifting collection area, by the ISO standard, it will be separated into two parts. The first part we call it the ground collector. This is like this. The ground collector. This is used for collecting the drifting. That's the drifting deposit on the ground. Another part is the airborne part. Is called airborne drift collector. Like this. There are many strains that can observe the chemical in the air to present to present us the air drifting result. And there are total 6 airborne drift collector in the air to collect everything in the air. And except for the drone spring, we also use the ground boom sprayer to make some comparison. And here is all the result about under different condition. On the top two are the result from the ground machine, the ground collector. Sorry, the ground collector under different flying parameters and wind speed. Here, we defined the wind speed as two different kinds of speed. One is the low speed wind, another is high speed wind. The speed boundary is 3.4 meters per second. It's around 11 feet per second. This is the boundary we got in this experiment. And those two on the below part, those two on the bottom are the result from the airborne, the drifting in the air. The same we collect under different result and different wind speed and different flying heights, different flying speed, and with different droplet size. So here is the conclusion from the drifting test. And here we can get influential factor ranking. The biggest influential factor is flying height. Maybe previously, for many people, this is a very common sensing and instinct. Everybody will know the flying height will influence the drifting. But here we got experimental scientific verification. The flying height is the biggest influential factors for the drone's drifting, spring drifting. Second is the flying speed, and its influencing is stronger than the wind speed. And the last one, the droplet size. So based on our testing result, we can find when the flying height is more than 4 meters, it's around 13 feet. It's around 13 feet. The blue curve on the ground and the ground collection and the air collection, the blue curve on the top is the one is the result for the 4 meters. So as you can see, there are only one curve represents 4 meters flying height. So as you can see, it's far more than the other heights. So the flying height is the biggest influential factors to influence the drifting. And next one is flying speed. As we can see here for the top of the three flying parameters, only the flying speed is different. So as we can see, it's the 7 meters per second is bigger than the 5.5 meters per second and bigger than the 4 meters per second. So this is the influence from the flying speed. Next one is wind speed. Wind sometimes is a very random factors that can influence the result. It could result in a very random drifting result from 7 to 120%. So it's a very random factors. And next is the droplet size. The bigger the droplet size is, less drifting is. Everybody knows this, so it's just a verification process. And next is some overall conclusion. The first one is far from 20 meters. It's around 65 feet away. Far from this distance, the drifting deposition on the ground becomes almost zero, less than 0.003 micron in the downwind direction on the ground collectors, all the ground collectors. And also, we found in some certain flying parameters, mostly when the flying height less than the 3 meters, the flying speed less than 5.5 meters per second, the drone's drifting result will be very similar with the ground boom sphere. As we can see, the red line, the red curve, is the result from the boom sphere. The ground boom sphere, the red line. As we can see around this red line, those curves are the flying parameters. Is flying height less than 3 meters and the flying speed less than 5.5 meters. So those flying parameters can perform very similar with the ground boom sphere. So the drones drifting here, I want to say, is the drones drifting sometimes is not big as what we thought. Sometimes they will be very similar with the boom sphere. So here we can give some flying parameter recommendation when the drafting is a very key concern, especially for the herbicide and insecticide application. First, the most important one is flight height. So we suggest you choose the flight height between 5 feet to 10 feet, and the flight speed no more than 23 feet per second, to leverage strong downward pressure to increase deposition. This point, Ryan has elaborated many information about this one, the downward pressure below 23 feet per second. And for the wind influence, we would suggest not do the operation in spring at a wind more than 11 feet per second. This is the boundary, what we define as a strong wind and low wind. So otherwise, you cannot guarantee any efficacy, we will say. And also, we will suggest everybody to set the buffer zone between spring zone and the protection zone. And based on our experimental result, at least set up a 65 feet protection buffer zone from your operation area to your protection area. And also DRA, drift reduction agent, will be very helpful to reduce your drifting. And also we can do something on the droplet side to select the coarse and very coarse type droplet size. So all above are the suggestions when the drifting is a very key concern. And the next one is a solution recommendation for rolling hills. And rolling is very common in our daily work. And drone has the active phased radar and can help the drone to follow the terrain to keep the consistent height above the crop canopy. That's what we want when we phase the rolling hills and when the terrain change right. And here for wheat and other row crops, and also the soybean and corn, and we are better to use different solution with different slopes. And one very, very obvious judgment condition is the slope degree. I would say if your slope degree on your fuse, the slope degree is always smaller than the 15 degrees, I would say the flight route to the autonomous flying mode is very suitable. You can use to fly it directly and open the terrain follow option and open the obstacle bypassing option. And maybe sometime if you want to, if you want to keep a very stable signal connection between RC and drones, and I will suggest to you to use the DJI relay to provide a more stable and more strong connection between the RC and your drones, especially when you are doing the spraying or spreading on the rolling hills. Because sometimes when your drone fly over one peak to the bottom and another hills, sometimes the hill will blocks the connection between your remote controller and your drones. And if you set up a DJI relay on the top of your trailer, use a very tall pole to install it, and the hill will not stop the connection between the drones and the relay, so that you can keep a very stable signal connection. And if the slope degree inner field is always sometimes more than 15 degrees and even sometimes reach to 45 degrees, I would suggest to use the Pro solution mapping and task, and to use MS3M to scouting your map and collect all the RGB imageries and upload to the Terra or smartphone web to do the mapping, and then generate a 3D flat route, and then download to your T40 or T30 to do a fruit tree mode terrain fall operation, and open the terrain fall ability, and then the drone will get a super higher ability to adapt on the rolling hills that's the slope degree over than 15 degrees, or even sometimes reach to 45 degrees. 45 degrees. But please be noted, in this mode, if you want to do spraying using fruit tree mode, fly 3D flat road, we will, the RTK signal is very necessary in this part. And you can use DJI RTK Street mobile station, and also you can use custom third-party custom network RTK like Casis RTK or some other party network RTK service like Cord. You can use it on the T50, the T40, sorry, on T40. So here is a two different solution for the rolling hills, and I will show you some video about the result. This is a slope. Its slope degree is around 7 degrees. So here we use 2D flat road, the farmland flat road, autonomous flat road directly. So you can see it follows the terrain very good. And here this one is a fruit tree 3D flat road. And this is a slope, it's degree more than 30 degrees. 30 degrees. As we can see, we even cannot see the slopes surface into the bottom. But as you can see, the drawing can follow it with the help of 3D flat roads. And finally, this is the last page that we have the case study in Western state. And here, this is a project, they call it Precision Agriculture with DJI drones. Its location is in eastern Washington state. This farmer is managing more than 2,600 acres winter wheat every year in eastern Washington state, and he's doing a precision agriculture project. And this is actually a data-driven solution. The complete solution workflow is like this. And the first, many different kinds of sensor is used for the data collection, like M3M, satellite, weather and soil station to collect all the environmental information and feedback to our AI agriculture platform. It's called FarmVibes. It's an open source platform, for agriculture application. And if you are interested in it, you can have a look on this website. It's their citation results, and then use this platform and the user result to instruct the operation of T30 or T40 and tractors. operation. And he will use drones for the herbicide and fungicide application. Especially, he will use the drones to catch up the operation window after rain. It's a very, very big advantage that I mentioned as the first. So yeah, as you can see, the flying parameters is different in different scenario. But all in all, this is a very successful case till now regarding to the drones application on winter wheat, and almost using all the modern advanced technologies, the drones, AI, very cool. All right, I think that's all the content today about the presentation. Thank you, everyone. Thank you, Ryan. Yeah. And now, if you have any question, you can tap into the chat window. We can have a discussion. Ryan, can you hear me?
Yeah, I got you. Can you hear me?
Yeah. Okay. Hi everyone. If you have any question about the content today, you can unmute yourself or you just leave a message on the chat log. I guess you can unmute yourself. Here is a question. Yes, Ryan.
Does the RTK base station have to be placed in the same location every time the drone is flown in that field? I have not had to. Have you had to put it in the same location? I have not.
Yes, for the same place, the same boundary, the same flight route. If you use DRTK2 station, you need to keep it the same location. And here we also suggest you to make our permanent remark on the ground. So you just install the RTK2 station on the same places. And also, you need to remember the coordinates on the RTK2 station. And when you use it for the drones, no matter the M3M or T-series agriculture drones, you need to remember the coordinates the first time you use it, and the second time when you come back, you need to input the same coordinate on the RC remote controller, and then they can keep the total same accuracy. Mm-hmm.
Yeah, I don't use the RTK base station a lot.
Yeah, you do a lot of row crops operation. Yeah, it's I think so I think it's one way, and also here somebody they were um, left a remark on the ground.
Yeah, I think he's talking about them driving a stake in the ground, like a surveyor stake going in the ground to remember it, like a piece of rebar or something. It's generally what people do, so they remember.
Yeah, something like that.
Whatever they're going to put their RTK base station. But I believe, Kyle, that most.
Yeah, there are fixings placing it on the certain position. Thank you. I guess if you have any more questions, I think you can unmute yourself. All right, everybody.
This guy said, how do you have your trailer set up? Tank size, generator size, length of trailer, upper deck, etc. So when I started, I had that 16-foot trailer we talked about. I put a 330-gallon IBC cage tote on it, and I put a 60-gallon inductor tank on it, and that's primarily what I use to go spray tobacco. Small specialty crop, switching chemicals all the time. And then when fungicide on corn came, I switched to two 330-gallon IBC totes, and I would just mix a hot load in those. So both of those would be hot load mixed, and then I would just I manifolded those together into my pump, and then I just ran everything out of those two totes, and that'd get me through the day. From a generator standpoint, I've used a commercial off-the-shelf generator and my T30 charger. I don't really, it's tough. That works well. I can use the generator to do other things. That T30 charger is a 240 volt 50 amp single phase, where the DJI generator with the built-in charger for the T40, the D12000 IEs, a 12,000 running watt, and that's like a 3-phase charger in there, so it's going to charge a little quicker than the DJI generator. However, it's about 57-ish or so, about a minute quicker on the charger with the DJI generator. However, that's all that generator is going to do. So if I want to run my trailer and other things, I would recommend going with the T30 charger setup, getting a larger generator off of some, from some other location, and using that. Maybe it's your generator you got running your welder in the back of your truck on your farm now, or something else. But if you're going to use a lot of electricity and other things, then you go with a bigger generator. If you're using gas stuff and you're using a gas 1-inch transfer pump or something like that, you're not running a lot of other power, then you can use the DJI generator, and it does a little bit better job charging those batteries. Hope that answers that. Oh, and I did not have an upper deck to start with. Sorry, no upper deck to start with. I do have an upper deck now. However, my ground hand, my visual observer, does not like being up on the top deck. So I fly from the top deck, but I still landed on the ground just because he doesn't like to be up there refilling and swapping batteries.
Okay, next question. I think I need to answer it. It's about terrain follow. Cost ask, what if the slope of the terrain is higher than 15 degrees and you fly it in 2D mode? Yes, you can still fly it. And the only thing you need to do is to open the fruit tree or the mountain mode. But in those two mode, and even though you can fly it, but the following accuracy, precision is not better than, if you're doing a pre-mapping and use the real 3D flight route to fly it. The accuracy will be different. It's like if you do the pre-mapping work, it's just like somebody else. You are use mapping software to help you instruct the drone how to fly, and the software will help the drones know where is it, where is the exact position. So the drone is just follow the pre-configured flying position. But if you fly directly, it's just like you fly in a very strange, without navigation, without navigator. This is the mic ask with the DJI relay. Where is the easiest spot to set up? And I would say you can buy some high pole, a very tall pole, and install it on the top of your trailer.
We use a fiberglass telescoping pole. So it's a fiberglass telescoping pole. It's on the top of it. We can collapse it down. And then when it comes time to use it, we can just shimmy that pole up, lock it into position. It's almost like a, they call it a bang stick that power linemen use to break those fuses out and put them back in when they're working on power. It's a giant fiberglass pole like that. And we put it up around those.
Okay, we're going to the next one. Do you mean that the precision is different? It's just like this, and you remember, sorry, which drone do you recommend for mapping? We have lots of views that we never see, and you arrive in pasture and open, just trying to be efficient. I think till now the most efficient one is M3M.
Yeah.
For agriculture. Yeah, and next one, the precision for the terrain follow in 2D and 3D. It's just like this. I think you remember there is a parameter on the controller that is called the height above the crops, right? The height above the crops. So the terrain follow means even when the landscape changes the height, like the slope, the rolling hills, and the drone can still keep absolute height above the crop's canopy or the landscape, the surface of the landscape. It can follow and keep the consistent height from here to here. So when you use the 2D to follow the abrupt, the sharp slope, when you use the 2D to follow it, this height where, this height, it will be very hard for the drone to follow this height directly if the slope is too sharp. But if you use 3D, it means the software will help your drones to know the geo information directly. When the drone flies, the drone already know where is it, the slope in front of it. So the software will tell the drone the flying route directly, where you should go. It's like a navigator. When you drive from your office to your home, with a navigator, you know where you need to go, where you need to turn left, where you need to turn right. So the 2D mode is like no navigator. When you drive into a crossroad, you need to judge turn left or turn right by yourself. It's some process like this. So for the 2D, it can only rely on the drone's own ability to follow the drone, to follow the slope. For the 2D, it means you know the flying route preactively.
So what he was saying, Juan, is not that the precision is lower, but it's not able to follow it, right? So when you do a 3D flight route and you're in Smart Farm Web or DJI Terra and you're looking at the flight route, that route already is doing this. Where if you look at it in 2D, it's all just flat and it doesn't automatically follow. So if it's a slope of 15 degrees or lower, long, slow, gradual slope, 2D flight route will work really well. But when we go to greater than that, flying over with the Mavic and creating that 3D flight route, the Mavic is already mapping what that terrain looks like. And now the T40 is just trying to follow what it did. And never is there a time where it's off more than 15 degrees. So it's now able to fly it with the same precision accuracy. And we're able to keep our consistent height above the crops even throughout the whole field.
Okay. Curious about hamster, how long or how fast just mapping.
So acres and hours is going to depend on a lot of variables, like most things in drones. Are we just doing RGB? Are we doing, medium resolution and we're just flying it, at a 60% overlap, so it's not taking near as many pictures? It's going to take significantly less time. If we're trying to get RGB data and multispectral and we're flying at 100 feet or even down at 50 feet because we're trying to get a stand count, then it's going to take significantly longer. You're going to get a whole lot less done. You can probably get a few hundred acres a day done if you're just doing medium to lower resolution, just updating your field's imagery and basically updating your Google Maps background. You can get quite a bit done that way. But when it comes to, I'm flying this 400 acre field to produce NDVI data on it, that's going to take a while. Yeah. Talking about that, they don't have a NVIDIA video card, and you got to have a video card. No, you're still gonna need that video card because you're processing super high resolution imagery.
Yeah, it's I think have you ever heard about the AI application, the ChatGPT? The tower, this is a process like the AI application. It's an imagery processing process. So it will use lots of the calculation results. It's an image processing process. So the graphic card is necessary. It's just like you are using the AI application. The graphic card is very necessary. If you don't have NVIDIA processor, I would suggest you to use the smartphone web. Yeah, it just the only thing you need to connect to the internet. It's a cloud-based website. You can do the mapping, the 3D flat hero generation, and the precipitation map generation. AMD.
You have that chart for which date to use?
So far, I think we only supports the NVIDIA, AMD. If you are interested in this part, and I can send you can send me your email, and I will check if we have any roadmap to support the AMD. Is there are charts that indicates which gate to use at different flow rates or spreader? Yes, there. Okay, I will send you a video to elaborate how to use the different hopper gate and what kind of application rate you need to use which hopper gate. Wait a minute.
So this person said, I had this problem in the slope spraying. Was the distance between the rows too big? Were you spraying or spreading? What was you putting on there? Because that looks like your route spacing was off. Is what it looks like.
I have this person installed. Spraying was the distance between the rows too big. What's that? Is herbicide or fungicide?
Said they were spraying that, and it looks like their route spacing was too big for what their swath width was.
Yes.
So they just really poured it down here where it's dead, and then green through there. It looks like maybe they just had skips in there from not having the right settings with their route spacing. Herbicide and fertilizer. So the green is what you were trying to get. The green streaks.
Herbicide and fertilizer. So what is the flying height?
I would say that's a swath width issue. So when you're talking swath width on aerial application, whether it's airplanes, helicopters, drones, whatever, it's height above crop and forward speed. So the higher you are and the faster you go, the wider it goes, and the lower, the slower, the narrower your swath width is. So the yellow is actually overgrown wheat. So actually the yellow is overgrown wheat. So yeah, it looks like your route spacing was a little off, and you had some gaps in your coverage. Do you remember what your settings were on that? Uh, 2.5 meters high, so that's 6, 7, 8 foot and 21 foot route spacing. Yeah, I would say at that low height, you didn't get much spread. It didn't get very wide, because at 2.5 meters, so what is that? What is that, Michael? 6, 7, 8 feet?
Wait a minute. It's matrix unit. I need to answer it. 2.5 high, 7.5 meters between the rows. Oh my gosh. So how about your flying speed? Flying speed and application rate. Can you tell me your flying speed and application rate? Low.
Yeah. So you flew it as low as possible, so you didn't get it out. So it was very narrow. So
I think
spacing was too wide, and they were too low.
It should be the swathways.
Up,
yes, it should be swathways. Swathways issue. I think. I would see maybe 5 meters. I will leave my email address to you, and I think we can discuss about our application further. Hi, I'll leave my email address here. You please send me your email. I will help you to find your suitable swathways. I need to tell you the exact number that you can use.
I think we pretty well have answered all the questions we got, Michael. If you don't have anything else, I got to jump off here and get ready for another meeting.
Yeah.
So if anybody has any questions of me, I'd be happy to answer them real quick, but I got to jump off here and head to another meeting real quick.
So everyone, I just leave my email address here. If you have any furthermore questions, you can just send me an email. We can have further discussion. Okay. Thank you, everyone.
All right, guys. Thank you.
Thank you, Ryan.
Appreciate
Thank you
it, Michael.
again.
Thanks for having me.
Thank you again. Okay, everyone, I will end the session. I will end this meeting. Thank you for attendance. And I already sent my email address in the catalog. And if you have any more questions, you can send me the email. Thank you very much.